This is a great example of the SAT taking something that we should know well, a formula, and then twisting it up so it's a little harder to recognize. But if we can get back to basics and understand what the real topic of the question is, this becomes really, really easy. The giveaway is that they're talking about percentages. In fact, they're talking about a percent change. So if we've been studying for the SAT for a while, we should have a formula in mind right away. That is the formula that I call the open formula because it kind of looks like the word open. And specifically here, we're going to need the one that involves the 1 plus or minus p to represent the change in the percentage. So just to review this formula, this is something that I made up after my students really struggled for a long time on percentages questions on the SAT. It is meant to keep you organized when things get weird. So the O stands for the original amount. And we are told that we have originally 2 apples. So that would go in that spot. The P is the percentage, and so 1, in this case, minus P because we have a percent less. So the benefit of this formula is that it usually follows the exact words in the question really, really well, okay? So you don't have to think about the situation too hard. You can just blindly go with what they're saying, and it'll probably fit in the formula correctly. N stands for the new amount. And so in this case, what they're asking is how many apples remain at the end of the day? That's our new amount. That's our answer here. So I'll just leave that as N to make it clear that that's what we want. So we should look for an answer choice that looks like this, and none of them do. We see a couple that are kind of close. We see the 200 in lots of places. This 100 is kind of strange, but if we remember that the SAT just takes what we know very well and twists it up slightly, we can hopefully just take a breath and understand that this is not that different from what we've already done. Okay, we're looking for something that kind of looks like 200 times 1 minus p. Okay, let's be really clear. This is what our kind of ideal answer will look like. Now we see all these 100s here. We might be drawn to the fact that the 200 is outside in B and D. That might lead us to those 2 choices. And then maybe we get D because we see, okay, the minus P is there, so that's probably pretty good. And that is in fact the answer. If that's all you understand, that's enough to get these points on a very, very hard question. But I'll just really emphasize what's actually happening here. The problem is in the way that the question was worded when we talked about P. P here is not going to be a percent in the way that the formula uses it. If we're plugging in for P in the formula, this P should be as a decimal, right? So for example, if I had something like 20% in the question, when I plug it in the formula, it's going to become 0.20%, meaning we divide by 100. And so that's where this division is coming in. We are playing with the difference between a percentage in the way that we talk about it, and then a percentage is a decimal, which is how the math tends to work with percentages. Sometimes you learn percentage formulas where that 100 is kind of built into the formula. I purposely leave it out because I find that in most cases it's confusing and causes problems. But here we do kind of need to work it back in. But hopefully, just by normal kind of process elimination and thinking about the normal formula, we can kind of work our way towards it, even though there is this little bit of a twist. This would be a hard question, but the first step you have to have is recognizing the topic, recognizing that it's a topic that you should know well if you've been practicing for a while, and putting that formula on your page.